In this lecture, I am going to present what is two-hinged parabolic arch and how to determine the horizontal thrust in the two-hinged parabolic arch. Here, I would like to solve two problems. In first problem, when a concentrated load is present at the crown, then what is the expression for the horizontal thrust? And in second problem, a concentrated load is present at a distance a from the springing, then what is the expression for the horizontal thrust? Before going to the analysis of parabolic arch, we have to know what is two-hinged parabolic arch. In two-hinged parabolic arch, there are two hinges present at the two supports. These two supports. This is the parabolic arch. This is the parabolic arch, and the two hinges present at two support A and B. And the shape of the arch is parabolic. And here at each support there are two reaction components. At support there are two reaction components, that is H and VA, the vertical reaction and horizontal reaction, and at support B there are also two reaction components. So the total four reaction components. But the available static equilibrium equations are three. So the two-hinge parabolic arch is a statically indeterminate structure. Why? Because there are four reaction components, but the available static equilibrium equations are three. So the degree of static indeterminacy is equal to the total number of reaction components minus the number of static equilibrium equations available. So the ds is equal to 4 minus 3. So this is equal to 1. So the degree of static indeterminacy of a two-hinge parabolic arch is 1. So this is a statically indeterminate structure to 1 degree. Then coming to the analysis of two-hinge parabolic arch. So let us take a point P at a distance x from the support A and y height from the support A. This is the point P xy. Let us take a origin at A. This is the origin and this is the P point at a distance x and y from the support A. This is the equation of parabola. This is equal to y is equal to, this is y and this is x. The y is equal to 4hx L minus x by L square, where L is the span of the parabolic arch. L is the span of the two-hinge parabolic arch and h is the height of the parabolic arch. This is the height of the parabolic arch and this is the span of the parabolic arch, so that is equal to L. And the equation of parabola can be determined, so using this relation. So this is equal to y is equal to 4hx into L minus x by L square. Let Pxy be a point on the arch and ds be the elemental length. Ds be the elemental length on the parabolic arch. Let theta be the slope of the arch to the horizontal at P. Let theta be the slope of the arch to the horizontal at P. And dx and dy is the horizontal and vertical length of the elemental length. So here dx by ds is equal to tan theta, dx by ds is equal to tan theta, then ds is equal to dx into sec theta. But the horizontal thrust is h, the horizontal thrust are denoted by h. For varying I section at any point, if I varying at any point, so that case the horizontal thrust is equal to integration m dash y ds by ei divided by integration y square ds by ei. is equal to integration m dash y dx by ei into sec theta divided by integration y square dx by ei sec theta. If I is equal to I0 sec theta and I0 being the value at crown, so in that case, so when you will apply this expression here, and the expression becomes the horizontal thrust is equal to integration m dash y dx by EIO divided by integration y square dx by EIO. Then after the EIO is constant, so the expression becomes the horizontal thrust is equal to integration m dash y dx by integration y square dx. Thus, in a parabolic arch with a variation of moment of inertia in the form of I is equal to IO sec theta, so that case the horizontal thrust is equal to integration m dash y dx divided by integration y square dx. So using this formula you can find out the horizontal thrust. So m dash is the beam moment, m dash is the beam moment. Then coming to the first problem, a 2-inch parabolic arch of span L and rise h carries a concentrated load W at the crown. Determine the expression for the horizontal thrust developed at the spring edge. So here the span length is given L and the rise of the arch is given h, and having one concentrated load at the crown. This is crown and this is springing. A and B points are springing and C point is the crown. So at the crown there is having a concentrated load, that is W, and you have to find out what is the horizontal thrust developed at springing A and at springing B. This is 2-inch parabolic arch. So here the load is present at the crowns. So due to the symmetry, the vertical reaction at A and vertical reaction at B both are same. That is VA is equal to VB is equal to W by 2. Let us take a point PXY on the 2-inch parabolic arch. And what is the B moment at the section at the point? So you have to find out what is the B moment at the point P. So if the vertical reaction at A is equal to W by 2 and the vertical reaction at B is equal to W by 2, so you can find out what is the B moment at the point P. So the B moment that you can find out by considering the vertical reactions. From the vertical reaction you can find out what is the B moment at the point P. So this is the horizontal distance, this is the horizontal distance, this is the coordinate of the P, this is the x coordinate and this is the y coordinate. And you have to find out what is the B moment at P. So VA into x, the B moment that you can find out from the vertical reaction. So this is equal to VA into x. So m dash is equal to B moment is equal to VA is equal to VB is equal to W by 2. So W by 2 into x. B moment is equal to VA into x is equal to W by 2 into x. We know the parabolic equation y is equal to 4hx into L minus x by L square, and we know h is equal to integration m dash y dx by integration y square dx. So the integration m dash y dx, this is the numerator, and integration y square dx, this is the denominator, n numerator and d denominator. So first you find out what is the numerator value. So the numerator n is equal to integration m dash y dx, but we know m dash the B moment, so this is equal to W by 2 into x. So you have to put the B moment, m dash is the B moment, so this is equal to W by 2 into x. So you have to put the B moment here, so W by 2 into x into y dx. Then you know what is the parabolic equation, what is the parabola equation, you know what is the parabola equation. This is y is equal to 4hx into L minus x by L square. So you have to put the value of y here. So the numerator is equal to integration w by 2 x 4hx L minus x by L square into dx. Then after taking 2wh by L square into 2, and you have to integrate the value from 0 to L by 2 for both sides. So here you have to integrate from 0 to L by 2 this side and integrate 0 to L by 2 this side. So 2 0 to L by 2 when the x is equal to 0 here and when x is equal to L by 2 here, and from this side similarly you have to integrate from this side x is equal to 0 here and x is equal to L by 2 here. So integrate the expression from 0 to L by 2 and you have to take for both sides you have to multiply with 2. 2 0 to L by 2 Lx square minus x cube into dx. Then after integrating this expression, so we will get the numerator 4wh by L square Lx cube by 3 minus x fourth by 4 and the integration limit 0 to L by 2. The integration limit 0 to L by 2. Then after putting the integration limit 4wh by L square L fourth by 24 minus L fourth by 64. Then after simplifying the expression, so the numerator is 5 by 48 into wh L square. This is the numerator value. Integration of m dash y dx is equal to the numerator, this is equal to 5 by 48 into wh L square. Then find out what is the denominator. The denominator is equal to integration of y square dx. So the denominator is equal to integration of y square dx, but we know y is equal to 4hx L minus x by L square, and take the square of this expression 4hx L minus x by L square dx. Then after simplifying the equation 16h square by L4, and here also you have to integrate from 0 to L by 2 and you have to multiply 2 for both sides. L square x square minus 2lx cube plus x fourth into dx. Then after taking the integration of this term, you get 32h square by L4 L square x cube by 3 minus 2l x fourth by 4 plus x5 by 5, and the integration limit is 0 to L by 2. Then after putting the integration limit, so finally the expression 32h square L 20 minus 15 plus 3 by 480. Then after simplifying, finally you get the denominator is equal to 8 by 15 h square L. But you have to find out what is the horizontal thrust. What is the horizontal thrust? So the horizontal thrust that you can find out, h is equal to numerator by denominator. Here you got the numerator n, and this is the horizontal thrust is equal to numerator by denominator. The numerator is you got that is by integrating m dash y dx, and the denominator you got by integrating y square into dx. Then you have to put here h is equal to n by d and 5 by 48 whl square divided by 8 by 15 h square L. Then after simplification, so you get the horizontal thrust is equal to 25 by 128 WL by H. So this is the horizontal thrust when the concentrated load is present at the crown. Then coming to the second problem, so that the horizontal thrust developed in a parabolic arch of span L and rise H subjected to a concentrated load W at a distance A from the springing is given by H is equal to 5 by 8 W by HLQ into A into L minus A L square plus LA minus A square. So you have to prove this one. This is the horizontal thrust when the concentrated load is present at a distance A from the support A. So this is the expression of the horizontal thrust. This is the expression of horizontal thrust. So here in this problem, this is 2 hinge parabolic arch, and this is the horizontal thrust, and this is the vertical reaction, and here the concentrated load is present at a distance a from the support A, and this is the height, the vertical distance is the height, and here this is the rise of the 2 hinge parabolic arch, and L is the span of the 2 hinge parabolic arch. So here you have to take 3 cases. In first case, what you have to do, you have to what is the load is given, what is the position of load is given. So due to that position, so what is the horizontal thrust developed at both ends, that you have to take H. So in the question, so the concentrated load is present at a distance A from the support A, and the concentrated load is given W. So due to this load, what is the horizontal thrust developed, that you have to take H. So in case 1, let the horizontal thrust developed be H due to this loading. This is the case 1. Then in case 2, what you have to do, so you have to take the same concentrated load at a distance A from the support B. You have to take the same concentrated load at a distance A from the support B. This is the same concentrated load you have to take at a distance A from the support B, and due to this concentrated load, so what is the horizontal thrust developed at both support, that is also H. When the load is present this side at a distance A from the support A, the horizontal thrust developed H, and the same load is present at a distance A from the support B, and here also the horizontal thrust developed at both support is H. This is the case 2. And in case 3, what you have to do, so you have to apply both the load. The concentrated load you have to apply W at a distance A from the support A. Concentrated load W you have to apply at a distance A from the support B. So you have to take this side from the support A, and this side also from the support B. So both sides you have to take the concentrated load, the same load, and due to these two load, so what is the horizontal thrust developed? So this is 2H, because when the load is present this side, the horizontal thrust developed H, and when the load is present this side, the horizontal thrust is developed H. But when the load is present both sides, that is at a distance A from both the supports, so that case you have to find out from the law of superposition, the horizontal thrust developed will be 2H. Then you have to find out this horizontal thrust, because this is the symmetrical loading. So here you got, this is the symmetrical loading. So the load is present both sides at a distance A from the support A and support B. So as the 2 hinge parabolic arch is symmetrical, so what is the vertical reaction at A and what is the vertical reaction at B? Because the total load is acting 2W, and the vertical reaction at A is W, and the vertical reaction at B is also W, due to the symmetry of the loading. So here you have to find out the B moment first. Due to this vertical reaction at A, so you have to find out between 0 to A and between A to L by 2, because this is the origin. So this is 0 and this distance is A. So at a distance A, there is having a concentrated load. So you have to find out what is the B moment between 0 and A, and you have to find out what is the B moment between A and L by 2. So here you have to take a point P, and you have to find out what is the B moment here. So what is the B moment here? Here the point P, this is X and this is Y. So what is the B moment here? So B moment is equal to W into X. The B moment here is equal to W into X. So this is between 0 to A. The integration limit is 0 to A. So M dash is equal to W into X for the portion 0 to A. Similarly, let us take a point here P, XY. So this distance is X and this height is Y. This height is Y. Here take the point P, XY, and you have to find out what is the moment, B moment here. What is the B moment? So the B moment here you have to find out from this reaction and from this load. So from this reaction, what is the B moment here? So W into X, because this length is the X. So this is the point P, and the coordinate is xy. This is the horizontal coordinate and this is the vertical coordinate y. So you have to find out what is the beam moment here. So w into x clockwise positive, and due to this load, what is the moment? If this is x and this is a, minus w x minus a, and this distance minus w into x minus a. So the beam moment here, is equal to m dash is equal to wx minus w into x minus a. So after simplifying, wx minus wx minus wa plus wa. So this wx cancel each other, then m dash is equal to wa for the portion x is equal to a to l by 2. So between x is equal to a to l by 2, the beam moment is equal to m dash is equal to wa, and between 0 to a, the beam moment is equal to w into x. For 0 to a, the beam moment is equal to wx, and for a to l by 2, the beam moment is equal to w into a. The beam moment m dash is equal to w into a. Then you have to find out what is the horizontal thrust by considering this moment for the portion 0 to a and for the portion a to l by 2. And here you know the horizontal thrust is equal to 2h. So 2h is equal to the integration of m dash y dx divided by integration y square dx. This is the formula of the horizontal thrust. But we know from the previous problem the integration y square dx is equal to 8 by 15 h square l. You got from the previous problem the value of integration y square dx is equal to 8 by 15 h square l, the denominator value. Here you find out what is the numerator value, integration m dash y into dx. The integration of m dash y into dx, so that you have to take here. This is the formula m dash y into dx. So but the m dash you got here for the portion 0 to a wx, and you got the m dash for the portion a to l by 2. This is w into a. So here you take for 0 to a portion wx into y dx, and both sides you have to take 2 0 to a integration limit wxy dx plus for a to l by 2 portion, here you take a to l by 2 integration limit wa, this is the moment, the beam moment is wa into y dx. Then after putting the y value, you know y is equal to 4hx into l minus x by l square, the parabola equation. You have to put the parabola equation here, then 0 to a integration wx into 4hx into l minus x by l square into dx plus, you have to multiply these two here and here, 2 and a to l by 2 integration wa, and you have to put the y expression 4hx into l minus x by l square into dx. Then after taking the integration, so here you get 8wh by l square, l x cube by 3 minus x fourth by a, and 0 to a plus a l x square by 2 minus x cube by 3 a to l by 2 integration limit. Then after putting the integration limit in this expression, so this is the expression 8wh by l square 1 by 24 8aql minus 6a4 plus 3alq minus alq minus 12aql plus 8a4. Then you have to find out the integration of m dash y dx is equal to wha by 3l square into 2lq minus 2a square l plus aq. Then after simplifying, so 2 by 3 wha by l square, lq minus a square l minus a square l plus aq. Then after simplifying, 2 by 3 wha by l square, l minus a, l plus a minus a square into l minus a. So this is the integration of m dash y dx. The integration of m dash y dx is equal to 2 by 3 wha by l square into l minus a into l square plus la minus a square. So here this is the numerator value. and already you know from the previous problem the denominator value, this is 8 by 15 h square L. Then you can find out what is the horizontal thrust. The horizontal thrust 2h is equal to integration m dash y dx divided by integration y square into dx. So you got here the integration of m dash y dx, this is the expression 2 by 3 wha by L square, L minus a into L square plus LA minus a square, and you know the integration of y square dx, so this is 8 by 15 h square L. Then after simplifying the numerator and denominator, so you get 2h is equal to 5 by 4 w by HLQ a L minus a into L square plus LA minus a square. Then finally, so you have to find out what is the horizontal thrust when the load is present at a distance a from the left springing. So this horizontal thrust H is equal to 5 by 8 W by HLQ into a L minus a L square plus LA minus a square. So this is the proof of horizontal thrust. So this is the expression for the horizontal thrust, 5 by 8 W by HLQ into a L minus a into L square plus LA minus a square. This is H is equal to 5 by 8 W by HLQ into a L minus a L square plus LA minus a square. So this is the proof of the horizontal thrust when a concentrated load is present at a distance a from the support A. Now all are clear. So what is two-hinged parabolic arch? Then how to find out the horizontal thrust in the two-hinged parabolic arch? You are clear? These two problems. When the concentrated load is present at the crown, and how to find out the horizontal thrust, and what is the expression for the horizontal thrust. Similarly, when a concentrated load is present at a distance small a from the support A, then what is the expression for the horizontal thrust.